So for our next example, we now tackle problems in computing percent composition that involve complex symmetric reactions wherein there's more than one analyte present. So in this case, it could get very tricky. So what I tend to do here and what I could share with you is that what I try to do for me to be able to not get lost in the problem is to try to break down the particular statement of the problem into maps, like in this one. Again, this one is taken from Skoog, number 17-34 on page 439. I highly recommend that you read the problem first before you continue on with this particular video. In that way, at least we are on the same page. So for me not to get lost, I try to summarize the data as follows. So our sample, we now get 2 alicos. For the 25 ml alico only, never mind the 10 ml alico just yet, we now have the following information. So in the 25 ml alico, if you've read the problem carefully, what it says is in there is to precipitate AgBr. Now the BrO3 minus is not mentioned at all. So in our 25 ml alico, only the bromide ion is of interest in here. So bromate does not yet come into play, and so only bromide is assumed to be the only one will compute in here for the 25 ml alico. So the following relevant data were given for the 25 ml alico of our solution, which I've already summarized over here. Now, as to your 10 ml alico, if you read carefully, what it says in the book is that our bromate was reduced to bromide prior to the addition of silver nitrate. So I've noted it here. What this means to say is that unlike in here where only the bromide is the only one that will be able to compute, our bromate will now come into our computation. Since the bromate is turned into bromide, and together, the bromide being formed and the bromide originally present will be subjected to the same reaction. So same equation is going to be relevant as in here in our 10 ml alico. And for our 10 ml alico, it turns out that we will need this amount of our EDTA solution. So the question now for us is to compute the percentage of the sodium bromide and the sodium bromate present in our particular sample. So what you can do so that you don't get very lost in the sheer amount of information that is in here is that we focus on one alico at a time. Never mind the 10 ml alico just yet. Let's try to focus first in here, in the 25 ml alico. It's better to focus in here first because, as I've mentioned earlier, only the bromide is going to be the one that will precipitate in here. The bromate is not mentioned, so therefore it does not come into play yet. The bromate is only important when we come in here. So we like to be able to start off our computation with only one of the analyte present, not with two of them at once. So we want to do this one first. There's a lot of information in here, so please never lose sight of what it is we're after. We're always after the bromide and the bromate in here. As you can see, there's a nickel being mentioned. There's this thing, there's this thing, there's this thing. So never lose sight of what it is exactly we're trying to find. So there is no equation given to us as to the titration of nickel and EDTA. So I wrote it down over here. So as mentioned in the problem, the nickel that is liberated by the silver bromide will require this amount of EDTA solution. So then, again, we now have a pairing of a volume and a concentration, which is good for us because we can now multiply these two immediately and get the moles of EDTA. So multiply the two, the volume and the concentration, we should be able to get the moles of EDTA that was used in the 25 ml Alico. And then, if you refer to this equation over here, the EDTA that we used in this particular Alico was used to be able to titrate the nickel. So referring to the equation over here at the top, we're now able to write this particular